Hi everyone. So let's do thermodynamics questions. But before doing the questions, I want you all to go with your formulae, because formulae is the Jaan of this chapter. And I have given you a very short and crisp formulae notes. I want you to go through that again, and then we will do with the questions. I'm just now, for now, writing up all these, formulae till now, what we have done in one page. Okay. So first, irreversible processes. Work done is minus P external delta V. This is work done for irreversible process. And what if it is reversible process? Work done, because we are mainly talking about work, then heat, work and heat. These are the two path functions, very important to go with. Heat is represented by Q, or you can just show it as small q here. Okay, work and heat. So we have already discussed the work and heat definitions. What is the main difference between them, right? Then reversible at constant pressure. At constant pressure, work done is minus P external delta V, the same thing. And work done at variable pressure will be work done is minus integral of P external delta V. It is nothing but area under PV graph. Area under PV graph is nothing but your integration, right? The V1, this is V2. So, or if you're given a graphical question, PV graph you're given, then it is work done is nothing but your area under the graph, under the PV graph. That is your work done. And for this, this is all reversible processes. Kada? So reversible processes low, if you have isobaric, which means at constant pressure, this is the one, this is isobaric pressure. And if you have isobaric at constant pressure, and isochoric matlab at constant volume. At constant volume, change in the volume is 0, which means delta V is equal to 0, implies work done is 0 joules, right? Then at isothermal, which means at constant temperature. At constant temperature, work done is minus nRT ln V2 by V1. Or I would just say ln turns out to be your log, that will be minus 2.303 nRT log V2 by V1. That will be your work done isothermal. And at adiabatic processes, adiabatic is nothing but your heat transfer is not there. Okay, heat transfer is 0, whereas isothermal, which means temperature is constant. Now we have adiabatic. Yeah. Adiabatic process, we have P1 V1 to the power gamma is equal to P2 V2 to the power gamma. And what is gamma? Gamma value is 1.66 for monoatomic gas, 1.4 for diatomic gas, and 1.33 for polyatomic gas. This is the value of gamma. So for adiabatic changes, go with this. P1 V1 to the power gamma is P2 V2 to the power gamma. And work done here in the adiabatic process is nR T2 minus T1 upon gamma minus 1. This is your work done for adiabatic process. So all this is for the work done. Just now we have discussed everything about the work done, whichever case you're given. All these cases are exclusively given to you separately. So I want you to go with them very neatly and clearly, and please make a note of this as it is, and learn them. Okay, now let us talk about heat there. Heat Q is equal to mc delta T, where C is nothing but your specific heat capacitance. Okay, so in that case, W equals to mc delta T. This is generally for physics, but for us in chemistry, it is nc delta T. I would say ncv delta T at constant volume, and ncp delta T at constant pressure. Okay, these are the two things what we have for Q. Q is equal to NCV delta T and NCP delta T at constant pressure. Now, what is the relation between your CP and CV? CP minus CV. CP minus CV is equal to NR. NR, N stands for the number of moles and times R. CP minus CV is equal to NR and CV is equal to F by 2 times R. This is freedom, degree of freedom, and which is equals to 3. F value equals to 3 for monoatomic, then 5 for diatomic, and 6 for polyatomic. This is your CP and CV relation. This is for the Q part. Q, which is nothing but your heat. So whenever we talk about heat, at constant volume, this is the formula NCV delta T, and at constant pressure, it is NCP delta T, where CP minus CV is NR. Okay, and CV equals to F by 2 times R, where F value for whichever gas is given to you, if it is mono, di, or poly, F values are given to you here, and F values for mono, di, and gamma values for mono, diatomic, and polyatomic gases. Like helium is a monoatomic gas. Ozone is a triatomic, which means polyatomic, I would say. And oxygen, O2 molecule, diatomic specifically. So that is where we can use those values directly into this. Now coming up with the zeroth law of thermodynamics. And what is zeroth law of thermodynamics? It is A is in thermal equilibrium with B and B in thermal equilibrium with C. Then A is in thermal equilibrium with C. So that is your first zeroth law of thermodynamics. Nothing much about that for you right now. Now, main thing for you is first law of thermodynamics. This is first law of thermodynamics, is what you have been learning, the energy conservation right from the 7th grade onwards. It is energy conserve. Energy is always conserved. Energy is neither created nor destroyed. That is what your first law of thermodynamics says. And here it is delta U, or I can say delta E. Sometimes U or sometimes E, depending on whichever, syllabus and all. Sometimes internal energy. This is nothing but internal energy. Internal energy. Yeah, internal energy of the system is nothing but your work done plus Q, delta W plus delta Q. So it's nothing but work plus Q. All this two, if you add up, this is going to be delta W plus delta Q is going to be nothing but your change in the internal energy. And internal energy cannot be calculated just like that. Only the change can be notified. Okay, remember that. So delta Q is the heat and delta W is the work. Now, what do we take about the sign conventions? Heat given to the system. So heat is given to the system is taken as positive. Heat lost from the system. Lost from system is taken as negative. Okay, this sign conventions also. And work done on the system is taken as positive. Work done by the system is taken as negative. In physics, your sign conventions change. That's it. Rest all will be the same. So whatever you are putting up the work there, work or the heat in your internal energy, heat is nothing but if your heat is given to the system, endothermic process that is, and that is positive. Endothermic, and heat lost from the system, exothermic, heat is given as negative there. Work done on the system positive, work done by the system negative. This is your first law of thermodynamics. And there we have the second law of thermodynamics here is nothing but the heat content in the system. Delta H is equal to delta U plus delta NGRT. Now, what is NG? Ng is the delta Ng is number of moles on the product side minus number of moles on the reactant side. That is your delta Ng formulation. So this is also can be written as plus delta U plus delta PV, na? Because PV is equal to nRT is your ideal gas equation. So delta H is equal to delta U plus delta PV. Okay, so all these things are your setup for these. And yeah, we have talked about reversible and irreversible. We didn't talk yet about your cyclic processes. Cyclic processes के लिए work done is always zero for a cyclic process. Remember that. Cyclic processes, work done is zero. Now, what do you mean by cyclic process? The pressure constant variables, pressure, volume, and temperature variables when started up your equation, and then when started up your reaction, and as you finish up your reaction, if these both will have the same values, then it is called as the cyclic. Wherever you start, you are ending it up there, then it is called as cyclic process. In that case, delta V is zero. Change in volume is zero because there is no change. We are saying the state variables will not have any change in the cyclic processes. So, and your volume is a state variable. So therefore, your volume, there is no change, which means delta V is equal to zero, and work done will be zero only because minus P external delta V. Whatever the pressure you start up with, there is no change in the volume, which means the answer is zero. Right? So work done is zero for cyclic processes. So it is derived from the same thing only. Na? So I don't need to write it separately, but yeah, application part, you will be very careful doing. Now let us do some questions based on these theory and also the numerical both. Okay. Yes, Rachel. So let's do some questions based on these things now. Try to relate your theory, what you have learned to these questions, right? Now, thermodynamic processes and parameters, internal energy, enthalpy, all that related to these things, right? Now, tea placed in thermos flask is an example of what? Thermos flask will be your isolated system. Why isolated? Because for that given amount of time, your neither mass delta M is equal to zero, and also delta Q is equal to zero there. So there is no change in your mass and no change in your heat also. So therefore, it will be zero. So therefore, it is your isolated system. Next, gaseous system is placed with pressure P1, volume V1, and temperature T1. It has undergone thermodynamic changes where temperature is remaining constant. What do you mean by temperature remaining constant? It is isothermal process, not adiabatic, bacha. Temperature remaining constant. We are maintaining the temperature at that time, at that particular given temperature. That is isothermal process. Adiabatic process is when there is no heat exchange in the system. That is your adiabatic process. Okay. Next, thermal isolated gaseous system can exchange energy with the surroundings. It is exchanging energy. The mode of heat may be what? So the mode of energy may be your work, I would say. There is some heat exchange going on, which means work is done in the system, right? So therefore, work is the thing. Mode of energy is work, I would say. And which of the following is a state function? State function and path function. We have two things, Q and W. Q and W are path functions. And whereas Q plus W, which is your internal energy, which is your U, internal energy U is a state function, which is a state function here. Q plus W is your state function here. Then you go with the next question. Yeah, if R is the work done on the system and S is the heat developed by the system, then something is given to you. Delta E is nothing but internal energy. Now, what is your first law of thermodynamics? Delta U is equal, or delta E, whatever it is equal to work plus charge, work plus your heat, right? So your delta E is equal to work. Work is done on the system, taken as positive work, which is your R. And heat is evolved, which means a system is releasing heat. Releasing heat, exothermic, taken as minus. So therefore, negative S. So this would be your R minus S. Delta U is equal to R minus S, which means delta E is R minus S. Next, the system absorbs 10 kilojoules of heat. Absorbs, which means system is taking in your work done is equal to 10 kilojoules. Work done is 10 kilojoules, and does the work of the system is doing the work, then work done is negative. So take it as minus 4 kilojoules, which is now the internal energy of the system. What? Internal energy is nothing but your same thing, work plus your heat. Work is 10 plus minus 4, which is minus 4, which is 6. 6 joules increases positive ochinde, so therefore it is increases by 6 kilojoules. Then reading in the internal energy of the molecule, which of the following statement is correct, they say. Absolute value can be successfully calculated. No, cannot be successfully calculated. That's the reason we change. We take it as delta U. Change in U we take. We cannot find out the exact value of the internal energy because internal energy is a summation of many, many, many energies. Transitional energies, vibratory energies, gravitational potential energies, kinetic energies, rotational energies. All these energies together will be your internal energy, which is impossible to calculate the exact value, but the change in it can be calculated. Its absolute value cannot be determined. Yes, we got the answer there, true. And sum of the vibrational and rotational energies, no, it is not just the sum of the vibrational rotational, it is just now we have discussed sum of many, many, many energies together. Next, coming up 8, respective examples of extensive and intensive properties. Intensive are independent of mass. They are not dependent on the mass, whereas extensive properties are dependent on the mass. Intensive is independent, extensive is dependent. So what are the examples? So independent of mass, what will be your thing there? I would say your temperature is independent of mass, right? Independent. Heat content is dependent again. Heat is dependent because although both the temperatures, both the 1 glass of water and 1 liter of water, both are at the same temperatures, but the heat content in the system is different. 1 liter bottle, 1 liter water will have more heat content in it. It will take more time to cool down. It will take more time to heat up. So heat content is changing there. So temperature is independent of the mass, but energy there is dependent there, right? So entropy is dependent. So your option 3 is correct. Is that clear, bache? So any case, you have doubt in that, you will come to me the next class and you will ask me that doubt. Next, what is an extensive property of the system? What do you mean by extensive property of the system? Which is nothing but your dependent on the mass. Intensive is independent, extensive is dependent. So volume is dependent on the mass, temperature is independent. Refractive index is independent. Refractive index, there is a particular refractive index for each of the substances. And similarly, there is viscosity assigned for each of the substances. Grease ke liye types of greases also you have viscosity. You have oils, types of oils. Each and every particular oil has got its own viscosity. And viscosity is nothing but the fluidity. Fluidity will not change even if it is 1 drop or 1 liter. So those are independent there, right? So therefore, this is also independent, which is intensive. Volume is extensive. It depends on the mass, right? Because density is mass by volume and volume is mass by density. It is dependent on the mass. Where density again is intensive. Density is not dependent, but it is mass by volume. It is definitely volume is dependent. Next, a well-stoppered thermos flask containing some ice cubes is an example of what? So it is an example. Thermos flask anangane, it has to be an isolated system or adiabatic system, isolated system. Then a closed flask containing water in all the 3 states, solids, liquids, and vapor at 0 degrees in the situation. Average kinetic energy of H2O molecules will be same in all the cases. There will be no change in the average kinetic energy, whichever they are in, whichever states they are in. Okay, next, which of the following is an intensive property? So intensive is independent of the mass. So independent of the mass, I would say pressure, because pressure is force upon area. Heat capacity is dependent. Okay, heat capacity depends on how much mass is there in that particular system. Total kinetic energy is dependent because most of them depends on the molecules there, and molecules are inbuilt dependent on the mass. And volume also, yes, we just now have discussed, volume also is an extensive property. This is extensive, 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 whereas this is intensive property, which is not dependent on the mass, because pressure is what? Force upon area. How much ever the force is, the molecular force will not change. For force, that is being exerted by the gas particles on the container is not changing depending on the mass there. So therefore, force per unit area, kada, per unit area force will not change. Total force changes, but force per unit area will not change. So therefore, it is an intensive property. Then, thermodynamics, a process is called reversible when. Reversible enti, irreversible enti. Irreversible ante, like whenever you drop we have discussed it in the last class. So whenever the system is random, is going on very fast with finite number of steps, it is irreversible. Whereas reversible is infinitely small steps you go with, infinite time it is taking, then it is called as reversible. So the system and surroundings are always in equilibrium with the system, because very, very minute changes are happening every step to step. So therefore, it is called as reversible. So rest all will be wrong there. Next, 14th. If a gas at a constant temperature expands, then its internal energy will not change. Nana gas expands, contract, internal energy remains the same. Okay, remember that there is no change in the internal energy even if gas expands or contacts, because kinetic energy is equal to 3 by 2 PV. 3 by 2 PV or 3 by 2 nRT. 3 by 2 nRT. So here number of moles are not changing, R is not changing. So T, it is dependent only on the temperature. Then kinetic energy is only dependent on the temperature. At a constant temperature, they say, so therefore it is remaining the same only, right? Now, 15th question, internal energy and pressure of a gas having unit volume is related as energy. Same again, see, internal energy, let me talk about that as a kinetic energy right now for me in here. So kinetic energy is nothing but 3 by 2 nRT. And if I say nRT is your nothing but PV. PV is nothing but your work done, right? So that becomes 2 by 3 times the kinetic energy, no? So which means 2 by 3 times U. That would be your. See, this is nRT is nothing but PV. Internal energy nothing but U is equal to 3 by 2. It is hard writing it here, yeah. 3 by 2 PV. And PV is nothing but work. Now, how is PV defining as work? I am defining always PV as work. Why? Because work is equal to F into S, force into displacement. Force is what? Is nothing but your, if I have pressure, talking about pressure is equal to force by area, then force is equal to pressure times area. And this is S, area and displacement. Area and displacement is nothing but volume. So P times V is your work done here. So this is how you will get always PV as your work. Work are two types, like we have PV works and non-PV works. PV work is this one which we are talking about, and non-PV work is your electrical work, mechanical work, all these things will be under non-PV work. Okay, now moving on to the next one. Yeah, I hope you're getting them well. Yes. Now, temperature and heat are what? Temperature and heat. Temperature is an intensive property, right? Temperature is intensive, so this and this. And heat is an extensive property. Heat depends on the mass. Just now we have seen one glass and one bucket of hot water. There is almost this. See, even if they are both at the same temperatures, but the heat content in the system is different. So extensive. Independent of the mass, matlab independent is intensive, dependent is extensive. Here heat is dependent on the mass, therefore it is extensive property. Next, thermodynamic variable temperature is defined by which law? The zeroth law. Zeroth law, what it states? One is in equilibrium with thermal equilibrium with 2, and 2 is in thermal equilibrium with 3. Then 1 is in thermal equilibrium with 3. Next, Which of the following statements is wrong is being asked. Water in a beaker can be made to boil by placing it in a bath of boiling water. No. It cannot be, easily boiled by placing it in a boiling water bath. Water can be made to boil without heating. Yes, water can be made to boil without heating it by doing work on it. Okay, so work will bring that, thing. So by reducing the pressure, boiling point can be reduced. By reducing pressure, boiling point of whatever the substance can be reduced. Andukane, that's the reason even in higher altitudes, your pressure is reduced. As the pressure is reduced, boiling point decreases. Now, as the boiling point decreases, what happens? Your vegetables or your dal is not cooking at that, is not able to, cook well at that low boiling points and melting points. Now, it needs some 100 degrees, then only it will boil properly. But it is now the boiling point is reduced. So as it is being reduced, what is happening? You're not able to cook them properly. That's the reason. And the reason we will be using pressure cookers, which will develop more pressure in your system there. Okay. Then ice can be made to sublime by decreasing the external pressure. No. Okay. If two pieces of ice stick together, if they are passed against each other and release it due to regulation. No, no, no. Okay. Yeah. When an ideal gas is compressed adiabatically, adiabatic matlab kya hai? There is no heat exchange in the system. That is adiabatic process. Adiabatic and reversible process. Reversible, which means it is at equilibrium. The system is at equilibrium. The final temperature is always, I would say, higher than the initial temperature. Why? Because when the gases are compressed, as the heat is produced and that cannot be lost, no? Adiabatic, so heat is not lost. As they are compressed, there is a lot of collisions happening. Heat is produced, more heat there, so which means temperature is now at a higher rate as compared to the initial one. Adiabatic change, kabatti, there is no transfer of heat going on there. Okay, next, moving on to 20. A closed flask contains a substance in all the three states: solids, liquids, and vapor states. I think this is now, just now we have seen. In this situation, average kinetic energy of the water molecule is same in all the cases, because average kinetic energy is dependent only on the temperature. Remember this point. Kinetic energy is only and only and only dependent on the temperature, nothing else. Okay, next, 21. Thermodynamics, a process is called as reversible. Reversible when the surroundings and the system is always in equilibrium. I think just now we have done this. This is a repeated question on. Next. Here comes some numerical type of question which we are going to do. Yes, for this I want my board. 1 second. Yeah. Yes. So now where are we? 16 kilograms of oxygen expands. So it says 16 kilograms of oxygen. So 16 kilograms of oxygen expands at STP at 1 atm. 1 atm isobarically to occupy double of its original volume. Delta V is what? Is double, which means, or else I would say I would not write delta V. V2 is equal to 2 times V1 I'm writing. Then the work done during the process is what? Work done is nRT log V2 by V1, or it is also equal to minus 2.303 nRT log V2 by V1. So which is minus 2.303. N stands for the number of moles. Number of moles is 16,000. We have to take because 16 kilograms, na? Because number of moles is given mass by molar mass in grams. Given mass by molar mass for it is 32 times R value. Take your R value as 0.0, oh no, as 8.314, bacha. 8.314, because we are talking about your joules and all work. So it will be 1 second. Let us take the value of R as 2 here, not this, because it is talking about kilocalories. So for calories and all, your R value has to be 2. Remember 1.98 somewhere closely, we take it as 2 here. And log V2 by V1. V2 is nothing but 2V1 by V1. It has been told to us double the volume karke V1 gets cancelled. Log 2 value 0.3010. When you multiply all these things, you will get your answer. There I'm not doing that multiplication. You will do that. Is that clear? I am moving on with the next question then. If you are a little slow going, please pause it and then you do it. Then you again see the question. Now, 1 mole of a non-ideal gas, that is what it says. Okay, let us write down the question properly first. Here, 1 mole of a non-ideal gas undergoes a change of state to ATM. It is 2 ATM, 3 liters and 95 Kelvin. This is PVT. To 4 ATM, 5 liters and 245 Kelvin. With a change in the internal energy, delta U is 30 liters per ATM. The change in the enthalpy of the process is how much? Change in the enthalpy, delta H is equal to what? Delta U plus delta NGRT, or it is also equal to delta U plus delta PV. I know what is delta PV is P2 V2 minus P1 V1. Okay, delta U plus this. So what is delta U, which is 30 liters plus you have P1 V1, you have P2 V2. Just apply that, you will get your answer there. I'm not doing it. Okay, is that clear? So you just have to apply that. Ante. Next, which of the following can be 0 for isothermal reversible expansion? Isothermal reversible expansion, delta E is 0, yes. And isothermal and temperature change should not be there, which means delta E is equal to 0, which means heat content, there is no change in the heat content also, there is no change in the temperature also. So isothermal reversible, everything is right. So please write it down separately. Isothermal reversible, delta E is equal to 0, or you can write it as delta U is 0. Anything is fine. Delta U is 0, and then your delta H is 0. Why is delta H 0, ma? Because delta H is equal to delta U plus delta NGRT, or delta PV, anything. So if it is isothermal, temperature change is 0, delta T is 0, so this is 0, and delta U is also 0. It is isothermal change, there is no heat change there, so isothermal, so delta U is also 0. So therefore delta H is 0, delta T is 0, all of these are 0. Okay. Next, moving on with 25, question number 25 there. Yeah. In an insulated container, water is stirred with a rod to increase the temperature. Which of this following is true? As you stir up water, see, we know delta U is equal to W plus Q, right? This is what we know. And it is being told to us that it is being stirred to increase the temperature. Okay, to increase the temperature, temperature is increasing there. Heat content is not increasing. Heat is the same only there. Okay, so heat content in the system is the same, and then the work is being done here. So work, there is a difference. So delta W is not equal to 0, whereas heat remains the same. Okay, next. 2 atoms of hydrogen combine to form molecule of hydrogen gas. the energy of H2 molecule is lower than that of the specific separate atoms. Okay, lower than that of the separate atoms. Why is that? Because two atoms of hydrogen are combining to form a molecule. And as two atoms combine, it releases a lot of energy there. So therefore, then the energy of hydrogen molecule is lower than the separate atoms, right? So next, vapor density of a gas is 8, molecular mass will be this. Question need not be here. Anyways, vapor density, 2 times vapor density is your molecular mass, Next, 28, if X moles of a gas at 27 degrees Celsius expands isothermally, okay, and reversibly, which means what? 1 second, yeah, X moles of a gas, isothermal, reversible from volume Y to 10Y. Then the work done will be how much? Work done is nothing but minus nRT ln V2 by V1, or it is minus 2.303 nRT, or everything is in ln, then it will be, let us put that in ln only then. Where is my eraser? That's fine. Yeah, ln. But ln, you have n stands for number of moles. It is x moles, and r stands for r only. 27 degrees is 300. So minus 300 xr ln V2 by V1. V2 by V1 is how much? V2 is 10y by V1 is y, which is 10y by y, which is 10. So it is ln 10. ln 10 is not there. I think there must be some mistake, Nana. This is not 0 there. This is not the same. So ln 10, this is fine. Yes, that would be your answer. Okay, minus 300 x ln 10 will be your answer there. Next, for question number 29, a system X undergoes following changes. As you can see, there is some changing going on here. P1, V1, T1 to P2, V2, T1, P3, V2, T2, whatever it is finally reaching P1, V1, T1 only, na? Initial starting point and the final point, if it is the same, it is called as the cyclic processes, and cyclic reversible process, that is cyclic reversible process. Next, question number 30. Different types of systems are shown here. You have work getting transferred there, here, and there. Here, see, if you can see this, there is no change in the matter, no change in the energy, which means that it is an isolated system. So your answer is here or there. It would not be adiabatic for the first one because there is heat content changing. So therefore, it is not adiabatic. This is just a closed system. Is that clear? You can just make a note of that. Next, set of intensive properties is shown here. All of them are intensive. Intensive, which means what? Independent. Independent of mass. Independent of mass. Your refractive index is independent of mass. Viscosity, we just now have seen a specific heat also is independent of mass. Next, coming up with 32 for the expression occurring from initial to the final stage in finite time. Finite time is your irreversible process, which is incorrect. Work obtained is maximum. This is incorrect. See, equilibrium exists, which is right. Then in the initial and the final stage only, not everywhere equilibrium, only in the initial and the final stage. Driving force is much greater than the opposing force. Yes, only then the reaction can proceed both 1 and 2. It is not. So 2 is the only thing which is wrong here. Okay, and in adiabatic process, transfer of heat takes place between system and surroundings. Yes, heat is being transferred between his system and surroundings. Choose the correct option for the free expansion, they say. And free expansion, which means external pressure is 0. External pressure is 0, and delta Q is not equal to 0 because heat transfer takes place. They say Q is not equal to 0, this or this, and Adiabatic conditions, it says also the temperature will be the same, work done will be 0 also. Okay, so this is the answer for it. Now that is how you can go with some of the questions there. I want you to go with some more questions from your textbook, from your pace books, or from your IPE books, whichever it is, and then let me know wherever you're finding it difficult. All right, bye bye. Then see you. Take care, bache.